right, welcome back. Today we're looking at the second part of the lesson, which is going to focus on the composite figures. I'm going to leave this example, or this warm-up for you to do on your own time if you'd like to. And you can always check your answer using the notes on Haiku to see if you got it right or wrong. All right, so new vocab word here is a composite figure. Is a figure composed of various shapes. So, for example, we might have a rectangle plus a triangle on top and maybe like a semicircle on the side. That would be a composite figure. We use addition or sometimes even subtraction to find the total area. So we're going to have to remember all the areas that the area formulas that we have. So the circle is pi r squared. The triangle is 1/2 base times height. The trapezoid is 1/2 height, and then the sum of our bases. And then the rectangle, either length times width, or some of us use base times height, either way. All right, let's go ahead and jump into some examples. Number one, we have the area of the shaded region. So we're just looking for this part here, the shaded part. The easiest way to probably figure this one out is to take the area of the entire rectangle. So I'm going to say the area of the big rectangle, and then just subtract the part we don't want. Subtract that middle part, or the small rectangle. So let's find some lengths here. The area of the big rectangle, we have this is 100, and then this is 25. This is going to be 25. So going all the way across, 25 for this part, 25 for this part, 100 for the middle part, is going to be 150 feet. The length, or the width, whatever you're using, the other direction, we have this is 20 feet, this is 25 and 25. So 25 and 25 is going to be 50, plus the extra 20 is going to be 70. So the area of the large rectangle is going to be 150 times 70, which will give us 10,500 feet squared for the large rectangle. We're going to subtract the small rectangle. That one's a little bit easier. It's 100 by 20. So when we multiply those, we get 2,000 feet squared. So the shaded area would then be 8,500 feet squared when you subtract them. We look at number 2 here. We're on the coordinate plane. So what we want to do is try to divide this shape up into shapes that we already know. So some people might go this way, which is kind of interesting figures. I think if we would go this way, we would create 2 triangles, one up here, and then a right triangle down below. So what we can do is we can find the area of those 2 triangles and simply add them together. So let's start with the red triangle. 1/2 our base times our height. We're going to count this as our base. So 1, 2, 3, 4, 5, 6 going across. Our height is 2, and you can just count the length right there. 6 times 2 is 12, half of 12 is 6. So the area of the red triangle is 6 units squared. And then the area of the blue triangle. Now this right here is a 90-degree angle. So we have 2 units this way. We have 1, 2, 3, 4, 5, 6 going across. So 1/2, 6 times 2. So again, we have another 6 units squared for the other triangle. So if we want to find the total area, you just add those together. 6 plus 6 would be 12 units squared. So if you're on the coordinate plane, try to divide the shape up into two shapes or multiple shapes that you know. Number 3, we have two semicircles on the ends, then we have a rectangle in the middle, and then we have a triangle over here. What's nice is that the semicircles, we have 2 of them, so really, if we put those together, we're going to have a circle. So let's find the area of a circle first. Pi r squared. 16 is the diameter, so that means our radius is 8. And I'm just going to leave it as 64 pi for now. So the area of the circle is 64 pi. And I'm going to underline that because that's an answer we're going to need to add at the end. All right, let's go to the rectangle. That should be pretty simple. So the area of the rectangle is base times height, or 32, and then this length is 16. So the area of the rectangle is going to be 512. Again, I'm going to underline that because that's information we're going to need to know. And the last one is the triangle. So this length is 32. This length is 15. They're perpendicular, so one's the base, one's the height. So 1/2 32 times 15. We multiply that together, we get 240 for the area of the triangle. Now we want the total area, so all we're going to do is add those together. So in your calculator, 64 pi plus 512 plus 240, and we should get about 953.1 feet squared for the area of the entire figure. And the last one here, I'm seeing 2 shapes. I'm seeing a circle and an equilateral triangle. I'm going to give myself a little bit more space. I'm going to erase this part over here. Let's see what we can do with this problem. So I'm going to draw the radius in here as well. So we have a circle. We want to find the shaded part. So what we're going to do is take the area of the triangle, the larger figure, so the area of the triangle, and we're going to subtract the area of the circle, and that will give us the shaded part. So the circle, that part should be pretty simple. Pi r squared, pi times 5 squared, or 25. Pi is the area of the circle. So I'm going to put that in our formula over here. Now, how are we going to find the area of this entire equilateral triangle? So you could draw it out on the side. Here's our entire triangle. I'm going to move that 5 and draw it here. Why am I going to do that? Because if I look at this, it is now the apothem, or the height, of one of our triangles. So I took this triangle and I split it up into 3 triangles. Basically, we're going to use what we did yesterday, or the day before, to figure out the area of one of these triangles and then multiply it by 3. So what we need to do first is find our central angle. What's the entire central angle here? So take 360 divided by 3, and we should get 120 degrees for this entire angle. Now we only want half of it because we're splitting in half over here. So let's split it in half. We get 60 degrees. And we're looking to find the base part down here. So if this is our 30-degree angle, this is our short side, 5 is going to be our short side, which means across from our 60 is going to be our short side times square root of 3. So again, we're using special right triangles. If you don't like that, you can use trig, and get the same thing. Now, if you put this in your calculator, you're going to get about 8.66 for this part of the base. Now, we want the entire base. We want this entire length. So you do need to multiply that by 2. As long as you have it in your calculator, multiply it by 2 right away. The entire base of the side is going to be 17.32 when you multiply that by 2. Okay? So that's 17.32 all the way across. Now what we can do is we can find the area of one of those triangles and multiply it by 3. So area of one of those triangles is going to be 1/2 our base, which is at 17.32, and hopefully you have that exact number in your calculator still and didn't round it quite yet. And then multiply that by the height, which is 5. So the area of one of those triangles, the smaller triangles, is going to be about 43.3. Because we have 3 of them, 1, 2, 3, we need to multiply that by 3 to get the large triangle. So the area of our triangle, the large triangle, the whole thing, when we multiply by 3, is 129. Oops, 129.9. 129 and 9 tenths. So we're going to substitute that into our formula up here, 129.9. We're going to subtract that inner circle, subtract that 25 pi, and that will give us our shaded part. So when you subtract, we should get 51.4 units squared for our shaded area. Now that is pretty complicated. And again, look at all that work that we drew. So that's what I would expect from you, is to have drawings, work, and all your numbers labeled so we know what they mean. Okay? If you have any questions, please let your teacher know. Assignments down below. Again, look for the modified version of your teacher coming out with that. If you have any questions, please let them know. This is a little bit more complicated than what we were doing at the beginning of the chapter. All right? As always, have a good day. It's a perfect day to be, a better me.